Good morning, students. This is Harsnath Sukla, and in class 10, today we are going to discuss irrationality of root 3. So, how to prove root 3 is an irrational number? So, for this, let us consider a possible root 3 is a rational. So, root 3 can be written as p by q, and this is nothing but p is equal to root 3q. On squaring both sides, we get p square is equal to 3q square, and this implies 3 divides p square, and this implies 3 divides p, and this is equation number 1. Now next, let p is equal to 3c, and then from equation number 1, 3c whole square is equal to 3q square, and this implies 9c square is equal to 3q square. So q square is equal to 3c square, and this implies 3 divides q square, and this implies 3 divides q. This is equation number 2. From 1 and 2, you see 3 divides p and 3 divides q, that is 3 is common factor of p and q. 3 is common factor of p and q, but this is contradiction. If 3 is common factor, then how root 3 is an irrational number, is a rational number? So this contradicts the fact that root 3 is a rational number. That's why root 3 is an irrational number. Similarly, you can do for root 5 and etc. Now we are going to see next example. 5 minus root 3, you know very well this, and seen the question in the exercise. Root 5 is an irrational number, so you can do by yourself. Root 5, in root 5 you just consider p is equal to 5c and other things. Okay, so in exercise 1.3, there are only 3 questions. You can do it. Next topic we are going to discuss revisiting rational and irrational number and their decimal expansion. So here we talk about the terminating and non-terminating decimals. So see this theorem. Let x is a rational number whose decimal expansion terminate, then x can be expressed in the form of p by q, where p and q are co-prime, and the prime factorization of q is of the type 2 power n into 5 power n, where n and m are non-negative integers. That means the decimal expansion terminate only when it can be represented as a rational number. P by q. Suppose 3 by 8. 3 by 8 is terminating or non-terminating. For this, if you see 3 by 8, then this is nothing but 3 upon 2 power 3. So you can multiply and divide by 5 cube, you get 375.10 power cube. And you see the denominator is in the form of 2 power m into 5 power n. That's why this is terminating decimal. If it is not so, then this is non-terminating decimals. So next theorem, you see, let x is equal to p by q be a rational number such that the prime factorization of q is the form 2 power m 5 power n, where n and m are non-negative integers. Then x has a decimal expansion which terminates That means it is clear. If we can write an expansion as a p by q, then it terminates only when if the denominator can be expressed as the 2 power m to 5 power n. So you can see here. Now next theorem, let x is equal to p by q be a rational number such that the prime factorization of q is not of the form 2 power n into 5 power m, where n m are non-negative integer, then x has decimal expansion which is non-terminating. If we cannot represent as the form denominator is in the form of 2 power n into 5 power m, then it is non-terminating decimal. So only you have to check the 2 power m into 5 power in exercise 1.4. So this is your homework, you can try, and then after we shall discuss next topic. Thank you.